Hello and welcome back. What day is it? That's a really good question. Sometimes when we're not in school on Monday, it kind of throws us off, but that's okay because we have our handy dandy calendar. It is Wednesday, the 17th, and we are here for number corner. And the activity that we're actually going to do today is a problem string. You may remember that I know we're talking about angles this month, and we've done some things with trying to estimate and figure out the sizes of angles, but it's really hard to measure angles or for Ms. Trammell to pull up a protractor and show you how to draw angles effectively via a computer. So we're not going to do that activity. Instead, we're going to go ahead and do our problem string, which means I'm simply going to show you what today's calendar marker looks like, which now you see it, and now you don't. I'm also going to go ahead and spin for how many degrees we are now adding to our calendar collector, which is 30 degrees. We were at 153, and now we need to add 30 degrees. So I'm going to go ahead and do that as well, and I'm going to do that when I'm not on screen with you because we have a problem string to do today. And you guys know as well as I know that when we do a problem string, it takes a little bit of time. And so we want to make sure we're saving our time to focus on the problem string of today, which I will tell you is all about fractions. While it is loading, go ahead and get out your number corner workbook if you don't already have it out. Turn to the back of the book just like we normally do. Go ahead and label it. This is problem string number 16, and it's fractions. We're going to be using some bar models to talk about fractions. So I'll give you a moment to get ready. And we will get started right now. All right. So our first problem, and I'm not really going to provide any context besides that we're going to be talking about like any real world context, but I will tell you that we're going to be talking about how to write equivalent expressions. So that kind of goes along with our solving problems that we've been doing this month, and how to decompose fractions to solve some problems. So here we go. Problem number 1. It says 2/3. 2/3 is equal to what? Write an expression that is equal to 2/3. So let's do that. What is 2/3 equal to? I'm going to go to my fraction app here. And let's see, can I move this? Perfect. So here is 2/3 represented. And hopefully you know that 2/3 means that I am talking about 2 1/3 size pieces, right, of my whole. So I created a model, and you guys may want to go ahead and draw a model and divide your model into 3 equal parts, which is thirds, much like I've done, and shade it in 2 of the 3 parts, 2 of those 1/3 pieces. And now we can talk about some expressions, like how we can write an equivalent, or how we can write an expression for 2/3. 2/3 is equivalent to what? So think about that. What is 2/3 equivalent to? We can go and start throwing out other fractions that we know based on maybe our understanding of how to find equivalent fractions. But I'm going to tell you that we can do something so simple. And it's based on what I just said a few moments ago. That 2/3 means we have 2 1/3 size pieces. So I'm going to represent another third here, and another third here. And I'm going to put a plus sign in between because we're writing an expression, and we know what an expression is, or at least I hope that we know what an expression is after all the work, the hard work we've been doing this year. Uh-oh. There we go. Okay, so what might that expression look like? What do I have here? I have 1/3, and I'm adding another 1/3 size piece. And guess what that gives me? 2/3. I could also say 2/3 is equal to 2, do y'all remember this? Times 1/3. Do you remember we talked about that before? Okay, we have 2/3, so I can do multiplication. So I'm either writing 2/3 is equivalent to 1/3 plus 1/3, or I can write 2/3 is equivalent to 2 times 1/3. Good? All right, let's move on to the next one. Let's see. Now we have 4/3. What's equal to 4/3? So we're going to do the same thing. And I'm actually going to start over here. And while I'm starting over, go ahead and draw your picture of 4/3. I'm going to make my picture. And since I know I have thirds, when I make my picture, I'm going to make a picture that has thirds. So 3 equal parts. And I'm going to shade in 4 of those thirds. You guys recognize what's happening here? Yeah, 4/3 is more than 1 whole. So that might be really easy for me to write equivalent or write an expression about, because I can do a couple things. I can do what we just did when we talked the last time. So let me move this over. And I'll move this over. So we got 4/3. I'm going to do my equal sign. And what do we know about 4/3? How many 1/3 size pieces do we have with 4/3? Good. We have 4 1/3 size pieces. So how many of these would I need? 4 of them. See if I can make it happen. And hopefully you guys are doing the same. Okay. And I'm going to kind of stack mine just because I don't have a whole lot of space, but that's okay. All right, so if I want to shade 4/3, and I'm talking about writing an expression, then here's what I can do. I know 4/3 is the same thing as 1/3 plus 1/3 plus 1/3 plus 1/3. Can you figure out another expression? Cool. Did anybody think about doing 2/3 plus 2/3? And I went ahead and represented that here for us. And so I'm going to write it as an equation. What we have done is we've said 4/3 is equal to 1/3 plus 1/3 plus 1/3 plus another third. We have 4/3. And if I do that, I can also say that 4/3 is equivalent to or equals, what's our multiplication equation? 4 times 1/3, because I have 4 1/3. Now, if you thought about the second one that I've represented, then you could also say that 4/3 is equivalent to 2 times 2/3. So 4/3 equals 2/3 plus 2/3, which is the same thing as saying 4/3 equals 2 times 2/3. We good? So we've been adding fractions, we're multiplying fractions, we're representing it with a picture, and now we're just going to simply talk about our equations. And if you still need the representations, then by all means, please go for it. Just for the sake of time for the video, I'm not going to have time to represent all of these. We are going to talk about them. So let's look at the third one. Now we have 6/3, and we kind of can envision what 6/3 looks like, because we already know that 4/3 is 2/3 and 2/3. So 6/3 is just adding another 2/3. So we could have 2/3 plus 2/3 plus 2/3. got 2, 4, 6 1/3 size pieces. I could also write it like we've been doing it with my unit fraction of 1/3 plus 1/3 plus 1/3. How many 1/3 do I need? I need 6 1/3 size pieces, right? And so there we go. Or I can write it in shorthand, which is probably much easier for Miss Trammell to do, which means I am using multiplication. So that means 6/3 is equal to 3 times 2/3. Or if I'm thinking in terms of unit fractions, then I have 6/3 is equivalent to 6 times a third. You following me? Is it making sense to you? I sure hope so. All right, we also can see, let me go back to this picture here. If I were to have 6/3, then look what it's going to look like. I'm going to fill in my other 2/3. Now I know that I have what? I have 2 wholes. If I were to add 2/3 to 4/3, it's also the same thing as saying 2. And I'm just going to write 2 here, because we can think about it as 6 divided by 3. 6 divided by 3 is indeed 2. Let's keep it moving. 8/3. Oh, we keep adding thirds. So we're adding another 2/3. So you guys go ahead and write, pause this video and write the different expressions that equal 8/3. Use what we've done earlier to help guide you. All right, did you at least get these two? 8/3 is what we just did, which is 6/3, and now we're adding 2 more thirds to it. Remember when we do problem strings, somehow the numbers or the problems are all related? So I just took 6/3 and I added another 2/3. Or I could think about 8/3 as 4 and 4, 4/3 and 4/3. So imagine, here was my 6/3, and what I'm probably going to have to do here is delete some of these so that we know we're only talking about 8/3 right now. So I had 6/3. You just have to pretend like I had 6/3 because remember the last 6/3 I didn't really represent, although I did kind of show it to you. So here's my 6/3, which we know is 2. And then if I'm talking about 8/3, I added another 2/3, right? Okay, well if 6/3, so let me circle 6/3. If 6/3 is the same thing as saying 2, then what can I write as another expression for 8/3? I have how many wholes? I have 2 wholes plus how many thirds? Plus 2 extra thirds. So I could say 8/3 is 2 plus 2/3. And we know that based on this equation right here. 6/3 was 2. And then we had another 2/3. And I can keep going all day. I could say 8/3 is 8 times what will be the unit fraction. Good. 8 times 1/3. I can keep going. I could say 8/3 is 2 times the 4/3 that we have because we have 2 4/3 here. But I'm going to stop there because I want to make it through the next few problems. So here's the big idea for what we've done so far. We decomposed these fractions. That means we broke them apart into smaller chunks, okay? We broke them into 2 parts. Some of them we broke into 3 parts. Or like this one, we broke into 6 parts, depending on if we used our unit fractions or not, okay? So there are many ways to write a number. Many ways to write a number. And today we're just focused on the ways of writing a number, which happens to be a fraction. We can write a fraction as an improper fraction, like 6/3 or 4/3 or 8/3, which simply means it's a whole number and then some more fractions, okay? So your numerator is more than your denominator. That's an improper fraction. It's going to be very helpful for you, especially in 5th grade, especially when we get to adding fractions like what we are about to do now. So we're going to think more about how we're going to write some equivalent expressions in decomposing fractions to solve actual problems. So here we go. First problem is 4/3 plus 2/3. Didn't we kind of do that already? We sure did. So I'm going to represent my 4/3 after I erase my circle here. Maybe. All right. So here's my 4/3. Y'all see it? And then I'm saying that I want to add, I'm going to make my addition symbol in between. I want to add 2/3 to it. What's going to happen if I put these two together essentially? Right, the 2/3 here are going to fill up the 2/3 there. And so look what I'm going to make a new model here so you can really see it. So I had my 4/3. I'm adding another 2/3. Here's what it ends up looking like. 1, 2, 3, 4/3 plus the 2/3. What do I get? How many thirds? I have 6/3. Yes, and 6/3 is equivalent to 2 wholes. So we did this problem. 4/3 plus 2/3 is 6/3. Whoop. That's a funky looking 6. Let's try that again. Is 6/3, which we know is the same thing as saying 2 wholes because we did it earlier, right? Now remember. So let's keep going. Remember, our problems are related, okay? Looks like we have now 6/3 plus 4/3. Whew. Well, can't we already add on 4/3 to the 6/3? We knew. What do we know about 6/3? Let's go back up here. Let's start over. We know 6/3 is 2. What about 4/3? 4/3 is the same as saying I have 1 whole and then I have another third. So can we use that to help us solve 6/3 plus 4/3? Yes, it is going to be the same thing as 2 plus 1/3 because we know 6/3 is 2 wholes. We just did it. 4/3, we just looked at it, is not 1/3, but it's 1 and 1/3. And so I can add my whole numbers together, which is going to give me 3 wholes. And then I still have a fractional piece. Look, now I have 3 and 1/3. Let's check it out. So here's my 2 wholes. And then let's say I'm adding that to, I'll do some working around here. I have my 2 wholes, plus I have my 4/3. So here's 6/3. Let me draw it out for you. Y'all see it? Whoop, my lights went off. Here's 6/3, and they're back on again. And then here's my 4/3. So how many holes do we have? We have 3 holes, plus we have our 1/3 left, which is what we just got. Are you ready for a subtraction problem? Let's see. Okay. Oh my. Now we have 6/3 minus 2/3. Yikers. See if you can solve that. 6/3 minus 2/3. Right, I had 6/3, and I am now taking away 2 of the thirds. So how many thirds am I left with? I'm left with only 4/3. We also knew that because, look, 4/3 plus 2/3 is 6/3. So it's kind of like that whole fact family idea, right? So I'm going to write 4/3 here. So now I want to see what you're able to do. You can use this fraction app just like I used it. You press the bar to figure out how many pieces you want. You can shade it in just like I did down here, and you have the pen tool. I want to know the answer to this question. And you can share your key with me. Got to give me your code so that I can see your work, or your teacher can see your work. 8/3 minus 6/3. So here's what I'm going to do. I'm actually going to give you a code. 8/3 minus 6/3. I'm going to clear my workspace here, and I am going to write it up top. 8/3 8/3 minus, let me backspace that, minus 6/3. And I want you to tell me what that is. And I want to see a model. I want a model. Okay, so here's the code. Are you ready? Oh no, there's no share code with this app. That's okay. You guys can do the work, and you can take a screenshot or save a picture of your work so that I can see what it is you have done to solve this problem. Thanks for working with me today. I know it's one of our longer videos, and I'm sorry about that, but sometimes that happens. And we did some really good work today. We talked about decomposing fractions, which then helped us figure out how to add fractions and subtract fractions. There's some other ways that we could have done this. We could, well, specifically for subtraction, we could have broken down 6/3 into, and I'll just show you this real quick. Since we know 6/3 is the same thing as 2/3 plus 2/3 plus 2/3, and then I'm subtracting 2/3, I know I can just take away one of my thirds, and then I only have 2/3, which is 4/3. So decomposing fractions is a really big idea, and you guys stuck with me, and I really appreciate it. So have a great rest of your day, and I will see you tomorrow.